So this is go to goal. So the robot is starting at 0, 0 with respect to its own reference frame, and it's going to 4, 4. So we're going to examine what happens if on the way to 4, 4 it detects an obstacle. Ideally it should use some type of finite state machine to switch between go to goal and avoid obstacle until it gets there. And Ryan is setting everything up for us.
I'm going to make it move it further back.
It has to move in discrete steps because we don't have encoders for feedback. So it has to do that in order to get the information it needs to make the decisions about the obstacle. That was a nice turn, guys.
That was just like visual indication that, hey, I see something.
Looks like you're making bigger steps at that point. So what should happen next is it's going to abandon the box at some point to continue towards the goal, all right?
That time it got too close to the wall, and like when that happens,
it went a little far on the obstacle, though, but I guess that's okay.
It wants to make clearance because we were catching it.
So then it was turning back towards the path.
Okay, let's try one more time. Here's our beep heading to 4, 4. X marks the spot. April keeps moving the box. Our beep's going to get confused. Looks like he always goes right. You said he will go left sometimes, though.
Which one's shorter?
Yeah, you did tell me that. You did tell me that for sure.
the difference on this one is where you can do this.
And since it can see the edge of the box on the right, it's going to want to turn that way.
Yeah. I see, what does that say? 200?
It's counting the steps that it's in this loop so that it knows how far it's going to add at the end when it needs to get out here.
Considering what Shy Kid on Thursday, December 18, 2014. That's actually what I wanted everyone to do, because that's what the video does. But different people got different things out of it, so it's okay. But to me, that's more Shy Kid, if that makes sense. You could actually drive the robot like this, with this kind, because it's actually moving proportional to the sensors. Does that make sense?
And then as you get closer, it goes a little bit
Did you do 3 at a time, or just 1 and 2 at a time?
It does all 4.
Okay, so let's see
So
another.
if you do left and right at the same time, it drives straight.
Oh, that's great. What if you do front and back?
It goes
It should
forwards and back.
spin or
and
something.
just-
Okay, let's see that. That would be interesting.
It just goes back and forth.
He's dancing. Okay. All right, that looks wonderful. Now let's do random wander. And now this is smart wander. So the robot should. So it's still kind of using your polar plot code, it looks like, because it backed up that time as opposed to just stopping, right?
Yeah, it backs up so it doesn't turn into anything, and then it goes somewhere else.
What kind of sensing distance did you say you're using?
6 inches.
6 inches. Okay. So you see with the momentum, even with 6 inches, it's getting to like 3 or 2, which is fine because it's still not hitting anything, which is your ultimate goal. Okay, that looks great. Let's get the world set up for go to goal. Okay, this is Franklin doing random wander with obstacle avoidance. He makes an audible sound when he detects an obstacle. He's still random wandering, but at that point he did see something. All right, great. All right, this is smart wander. Oh, this is random wander.
It's smart wander.
It is smart wander. So the robot ideally should still avoid obstacles while it's randomly searching the world. How did you guys calculate? Oh yeah, I could see the difference. How did you calculate the random wander movements?
We give each wheel a different wheel speed.
Do all 4 sensors work in smart wander?
They do. But it's, if it runs into anything ahead of it, it just turns around.
Is it calling on the other functions, like the other ones that you use?
Calling the function the shy uses.
Yeah, that's right.
And it also has an avoid behavior stack so that if it sees something ahead of it, it backs up. Because otherwise it would back up and then run right into it because it's longer.
Okay, good. That looks Okay, let's try one more time, Yashi, please. This is Moravec, Rain, and Yashi on Thursday, December 18, 2014, 1 week before Christmas. Okay, lift up the lid. All right, that's aggressive kid. It's a collide behavior, so all he does is move forward and stops me to check something. All right, great job.